Hey, so in this video, I will show you how to solve all problems in practice test. And so you have quiz this Friday, and actually this quiz is very similar to these problems. So I hope you do well. First problem, I can see that actually in this practice test, first 5, 6 problems are really easy. But anyway, let's do a review on that. Uh, First question, find the domain. Right? Find the domain and the range of this function and range. So your function is fxy equal to square root of x over y. The domain of the function is all points where the function is well defined, right? You can see in the definition of this function, you have square root of x and you have 1 over y. So basically, from here you can find the domain is where x greater than or equal to 0 and y is different to 0. So that is the domain. Next, find the range. So what is the range of function? Range of function is the set of all values, right, where function can take. So usually you have z equal to fxy, so that means you have to find all possible values of z. So let's look at the definition, right? Square root of x over y. So basically, z could be 0, right? Z could be negative. Z could be positive. So the answer should be all real numbers. Make sense? All right, next. Describe the level curves. Describe level curves and sketch contour map of the surface using level curves for the given c values. So what are level curves? So if you have function z equal to f of x, y, so level curves means you just put this equal to c, where c is some constant, and it turns out that fxy equal to c, is some curve in the x or y plane. So that is your level curve. Okay, when you change c, you have different level curves. So you can imagine, I repeated several times in the class, right? You imagine that. Suppose you have some hill, right? And then that is some surface, and then level curves. Each time when you move the height, right? You get and the height and the plane intersect with surface with the hill by some level curve. So that is your level curve. When you move that, you have different level curves. All right. Your function is z equal to 5 minus 4x plus y, and c is 0, 2, 4, and 6, and 8, right? That means if you put this part equal to c, so you have 5 minus 4x plus y equal to c, right? You can see actually y is equal to 4x minus 5 plus c. So level curves of these functions, are straight lines, and all straight line is parallel to this straight line, parallel to y equal to 4x. When you change c, right, actually you just move that straight line along along y axis. So first you need to sketch y equal to 4x, right? Let's sketch y equal to 4x. That is the main one. This pass through the origin when x equal to 1/2, y equal to 2. X equal to 1/2 is 1, y equal to 2. 2 is about here, right? So that is your straight line y equal to 4x, you see? And each time when you change, right? When you change c, you get, for example, when c equal to 0, so you move this straight line down on 5 units. Yeah, so for this question, probably I guess you choose the last one. So you have different last slides. Here is -5. Suppose this is -5. So you have -5, and then you move up, right? You move up. All right. So the third question. The third question, find the limit. Limit of xy over x squared minus y squared when xy approaches 1 and 1, right? And then we need to discuss the continuity of this function. Find the limit. And then discuss continuity of, I think, of this function, xy over x squared minus y squared. So, first we need to guess, right? Xy approach 1, 1. You have 1 square minus 1 square, you see? So 1 minus 1 is just 0. But how? So my guess is that the limit does not exist. But how to see that? So I will write this limit in the following way: xy over x minus y and x plus y. And here, xy approach 1, 1. Now you see, when xy approach 1, 1, this part is good. Because when you plug 1, 1 here, you get 1, 1 over 1 plus 1 is just 1/2, right? Because, and this part does not affect on the existence of this limit. So the only part affecting on the existence of this limit is 1 over x minus y. So I can say that it's limit of 1 over x minus y, and then here is xy, x plus y, xy approach 1, 1. You know, I just separate this function into two, right? Split it into two functions so that we can see clear. So basically, you know, you from here probably you can guess, right? If you approach 1, 1, you know, here's 1, 1, here's 1, 1. If you approach 1, 1 along this direction, probably you can get one answer, and you get along this direction, you can get another one, I guess. So you can try. Okay, let's say along when x is 1, right? When x is 1, okay, and then so that means along this direction, this limit is equal to limit of 1 over 1 y goes to 1, 1, and then 1 minus y, and then you have 1, 1 into y of 1 plus y, right? So it is obvious that this function does not have limit. I mean, even function of one variable. Makes sense? And of course, you can see when y approach 1 from the left and from the right, this limit could be negative or positive infinity. So does not exist. Since the limit does not exist, this function could not be continuous at this point, right? At 1, 1. And okay, so let's see how to discuss continuity of this function. The limit does not exist, right? Not continuous at 1, 1. Is there somewhere else where the function is not continuous? So we have to consider x minus y, x plus y. And it's obvious that, you know, at any point on y equal to x, you know, the function is not defined. And on y equal to negative x, the function is not defined too. So this function is continuous everywhere except points on these two straight lines. Where's this? Everywhere except this. You see, it's y equal to x, and here is y equal to negative x. All right, next question. Find all first partial derivatives. Here's the function fxy equal to ex cosine y, and find partial derivatives. So partial derivatives means, you know, in order to find that, we just, for example, here you have function of two variables. You find partial derivative f with respect to the x. So you just you just look at y, like number, right, like parameter, and you take derivative with respect to the x, like function of one variable. So here I have dfx, or sometimes we write fx equal to e2x is e2x cosine y, because this is just number, right? If you consider partial derivative with respect to the x. And df dy of fy. So for this you have ex is just coefficient, and then cosine y derivative is negative sine y. Or we write negative e2x sine of y. So I think it's pretty easy. You can solve this problem in 30 seconds, right? Next question, find all first partial derivatives. Just take a second function. Z equal to ln of x squared plus y squared plus 6, right? So zx or dz dx equal to. So now we differentiate with respect to the x. Here we need to use the chain rule, right? So I take the derivative of the top and then divide by x squared plus y squared plus 6. So don't forget that ln of u derivative is u prime over u. But the derivative of this with respect to the x is just 2x, and then I have x squared plus y squared plus 6. Okay. Similarly, you can take the derivative of this with respect to the y. So you see x and y have the same rule. So you write zy is just replace x with the y and you get the answer. So that is 2y over x squared plus y squared plus 6. That is the fifth question. All right, now let's consider second partial derivatives. Find partial derivative. That's fx and y equal to ax squared minus ax. X and y, sorry. X and y plus 5y cubed. So they ask us to find all second partial derivatives, right? Our function is a very good one. It's polynomials. So for second partial derivative, we have fxx, fxy, fyx, and fyy, right? For differentiable functions, fxy and fyx are equal. So this mixed partial derivative does not depend on the order when you take derivative. Okay, so basically for this function you only need to find xy or just fyx. All right, first we need to take fx, right? Fx is 16x, and then here I have minus y, and here is 0. And then from here I can get fxx is 16. Fy is, this gives us 0, this is negative x, and here I have 15y squared, right? And I have fyy is 30y, and then fxy. So how to take fxy? I can take this, right? And I differentiate this function with respect to the y. So I get negative 1. Or you can take this and differentiate with respect to the x. You also get negative 1. You see? Now that is all for the sixth question. Next, find the slopes in x or y direction. Find the slope in x or y direction. The function is z equal to x squared ln of x and of y plus 1. Okay, and they give us the point 5, 0, and 0. So what is slope in x and y direction? The slope in x direction is values of partial derivative with respect to the x, and the slope in y direction is partial derivative a function with respect to the y, right? So basically, the slope in x direction is equal to fx when at this point. Sorry. So similarly, you can find the slope in y direction, right? That is just fy 5, 0, 0. So basically, you need to take to find partial derivatives of this function, and then you plug 5, 0, 0 into that. So you have zx equal to 2x ln of y plus 1. You have zy equal to this x squared, and then here we use the chain rule, but that is okay. Here we have y only, so this is y plus 1. And then you plug 5, 0, 0 into this. You get x equal to 5, y equal to 0. So y equal to 0, you get 1 in here, right? So you get 0. When x equal to 5, I have 5 squared over 1 plus 0, which is 25. So that is the answer. You know, such problem you can solve really fast. Next, differential. Find the total differential of the following function: z equal to x sine x y, and we need to find dz. Okay, so that is total differential. Let's write out the definition of total differential. That is zx dx plus zy dy, right? Whereas zx and zy are partial derivatives. So what is zx in this case? You have x, right? You need to use the product rule. So for I take the derivative of x, I get sine of xy, and then plus x. Derivative of sine is cosine xy, and then derivative of the inside is y. You see, this is zx. You see, this function with respect to the x, so you need to use the product rule. This is product rule. Okay. Next, how to find z of y. X is just a number. X is number. Here you have sine of number some y, right? So z of y is x. The derivative of sine is cosine x y, and then times the derivative of the inside, which is x, and then here dy. So that is your total differential. Next, consider the following to approximate to calculate delta z, and then use the total differential to approximate delta z. All right, that is one application of total differential. That is the relationship between dz and delta z, right? dz is delta z. So what is dz? As we have seen that dz is zx dx plus zy dy, right? You know, once dx is delta x, dy is delta y, we have zx delta x plus zy delta y. That is total differential. And what is delta z? Delta z is f of x plus delta x, y plus delta y minus f of x y. Means when the point x and y move a little bit from that point, right, and you know get some delta x and delta y, the difference in function values is called delta z. But differential is a little bit different. So in this problem, we use differential to approximate delta x. The function is f of x and y equal to 6x plus a y, right? They ask us to find f1, f21. So you just need to plug 21 into this. You get 6 times 2 plus a times 1, which is 20. And then calculate f2.1 and then 1.5, right? So that is 6 times 2.1 plus a times 1.5. And and then you take the difference, right? The difference. Delta x is equal to f 2.1 and then here 1.05 minus f of 2.1. So that's how we can find delta z. How we can find delta z. You know, it depends on the function. You know, this function is simple, but as we consider on lecture, so if you have function and your function is not really good one, it's no way, you know, to calculate such value. Make sense? So sometimes in such cases, you know, we have to use differential to approximate delta x, and that is the second problem. And the second question in this, let's say, is it they consider 2 points, right? That is 2 points. They consider 2.1 and then 2.1 and then 1.05. So from here you can find delta x. What is delta x? Delta x is 2.1 minus 2, right? Which is 0.1. And what is delta y? Delta y is 1.05 minus 1, which is 0.05. So you already have delta x. You have delta y here. You plug delta x, delta y into this. You see? And of course, we need to find partial derivative of this function with respect to the x, which is 6, right? And partial derivative with respect to the y, which is 8. So basically, you differential, if you calculate the differential of this function, you get the following one. Differential equal to 6 times 0.1 plus 8 times 0.05. And when you see, the computation of this guy is much easier and similar than this. So once you get that, that is your approximation of delta z. All right, move to the next question. So for the next question, you need to use the chain rule. Okay, you need to use the chain rule to find partial derivative or find derivative. The first question, I write here the chain rule, right? I remind you again, right? We are learning calculus 3, so please use the chain rule in calculus 3. Your function is w equal to ln of x squared plus y, and x is 2t, y is 6 minus t. Of course, for such function, you can plug x and y into the function, right? And you differentiate, and you get a function of one variable. And it's easy to find just dw of dt. Okay? But how to use the chain rule for function of two variables? So the chain rules in this case say that is dw dx times dx dt plus dw dy times dy dt. We need to find partial derivative of this function with respect to the x. So that is 2x over x squared plus y. What is dx with respect to dt? That's just 2, right? And here, the derivative of this function with respect to the y is 1 over x squared plus y. And then take the derivative of this, you get negative 1. And you see, that is the derivative, partial derivative. And of course, if you want, you can plug x and y, you know, plug 2t and 6 minus t into this function, and you get what you need. The second part of this is what I just say. You have w equal to ln of 2t squared plus 6 minus t, right? And now you have function of one variable. You can find the derivative by using the chain rule in calculus 1, which is u prime. I can write in here 4t squared, so I have 8t, 6 0, so I have minus 1 over 4t squared minus t plus 6. Okay. Again, I would like to tell you that in this example, you can find this derivative easily. But as we did observation in the class, right? The chain rule for partial derivative would be easier in complicated situations because that in all we just need to find two partial derivatives, right? We can split the whole process into parts. So if this function is complicated, I bet we would do faster in this way. Okay. Next question. You have w equal to xy over 2, and then x equal to ar plus t, y equal to rt, and z equal to ar minus t. They ask us to find partial derivative with respect to r, right? So now you see the difference between this problem and the previous one is that here we have function xy, and xy are functions of two variables. X, Y, and Z are function of two variables. Oh, here is Z, sorry, of two variables. And this function is function of three variables. Now we need to use the chain rule. Of course, again, right? You can plug X, you can plug Y, and you can plug Z into this, and you get function of two variables, right? Two variables with respect to R and T, and then you take partial derivative. That's okay. And that is the second part of this question. I will not do that. You do that yourself. I just want to show you how to use the chain rule for this problem, right? The chain rule in calculus 3. So by the formula I get, that is dw over dx. And here we have dx, partial derivative of x with respect to r. In the previous example, we see we take derivative per partial, right? Because in the previous example, x was function of one variable, so we don't need to consider partial derivative. But in this case, x is function of two variables, so we have to write partial derivatives in here. Okay, plus dw dy, then dy dr plus dw dz, and then dz dr. All right, now let's calculate together. dw with respect to the x, it's just y over z. dx with respect to the r, it's just a. Second, dy with respect to the y, it's just x over z. dy with respect to the r, it's just t. Plus dw over dz, that is negative xy over z squared. dz with respect to the r, it's just a. So you see, very fast. All right, next question. Implicit differentiation. So, for this problem, you have formulas. Okay, let me remind you those formulas. If you have x, y, and z equal to 0, where z is a function of x and y, then you can find derivative, partial derivative of z with respect to the x, that is equal to fx over fz. And partial derivative of z with respect to the y equal to negative fy over fz, where this is partial derivative of this function with respect to the x. Okay, we can prove that easily, and we have seen in the class. Now just consider the following example. Z equal to yz x squared plus xy plus y squared plus yz plus z squared. Okay, and this is equal to 0. So our function z is defined using this. Okay, so let's take partial derivative of z with respect to the x. That is the partial derivative of this function with respect to the x, right? Negative. I have 2x plus y, 0, 0, 0. And here f with respect to the z, 0, 0, 0. here I have y plus 2z. You see, it's pretty easy. Similarly, you can find, dz with respect to dy, that is negative, dy x plus 2y plus z, and then derivative with respect to the z is y plus 2z. All right, move to the next question. Now, consider the following one. Find gradient. Okay, gradient, right? Let's find gradient of this function. Let's say f of x, y equal to 9x squared minus 4y squared. And c is 65, and then p is 32. First, they ask us to find gradient of this function at 32. So we know what is gradient of a function. Gradient of a function f is fx, fy. In case the function of 3 variables, so we still have fz here, right? It's just partial derivative. It's vector partial derivative. So in order to find this, I just take the derivative of this. I get let's say 18x, and then here I have negative ay, where x and y is 3, 2. So you plug 3 and 2 in here, you get 54 and then negative 16. That's it. Next question. Find a unit normal vector. Find a unit normal vector to the level curve. fxy equal to c in this case is 55, right? Okay, and at 3, 2. So unit vector. Here we have unit vector. That means once we get vector, we have to normalize. That means divide by x norm, right, to get unit. But we have normal vector here to a level curve. So what is normal vector to a level curve? Actually, that is gradient. Normal vector to level curves, that is gradient. So basically, they ask you to find, gradient, right? I mean, not unit vector. It means the unit vector along gradient at that point. We just found gradient vector over there. That is 54. So in order to find unit, you just need to find, you take this guy minus 16, and you divide by the norm of this. So that is your unit normal vector. And the next question, find tangent line to the curve, to a level curve. So for the tangent line, you have some curve in here, right? You need to find tangent line in this, right? But you already have n, right? This normal vector, unit normal vector. This is gradient vector. Basically, you have gradient vector over there. So how to find, tangent line of this? You have different way to do that. You have different way to do that. One of the ways is that here's P, right? Here's 3, 2. If you pick any point here, x and y, for example, that is Q. So PQ is orthogonal to n, right? Is orthogonal to n. Since these two vectors are orthogonal, the dot product is 0. Dot product with n is 0. But what is n? N is the gradient. What is PQ? We can write that easily. Let's say PQ, I would say that is x minus 3, y minus 2, dot product with 54 and negative 16 equal to 0. Overall, I have 54, x minus 3 minus 16, y minus 2 equal to 0. You see, dot product is equal to 0. So I take dot product of these two vectors, right? And this is 0. And then I have 54 in here, and then negative 60. So this method works, I hope you still remember how to write equation of tangent plane to some surface at some point. Would you exactly the same? I think we have one problem like that in the next. Right? Next question. Find an equation of tangent line. Yes, exactly, to the surface at the given point. You see? So we have z equal to x squared plus y squared plus 8 and 1 to 13. They ask us to find a tangent line to this surface at that given point. So again, this is tangent line, right? But if you put this, you put zf capital X, y, and z equal to x squared plus y squared minus z plus 8. So this equation is nothing but fx, y, and z equal to 0. That means that is, level surface, right? That is level surface of this function. So you have some level surface in here, and you take the tangent line. Basically, you need to find, this is some surface, right? You want to find tangent plane, right? So that means you have to find gradient vector, normal vector, and that is nothing but gradient vector, right? And then you have 1 point, 1 gradient vector. You can find the equation of that tangent line. So basically, you need to find gradient of f, which is 2x, 2y, and negative 1. And you plug 1 to 13 into this, you get 1 to 13, you get 2, 4, and then negative 1. That is the gradient vector at 1 to 13. Now we have 1 point. You do the same thing in the previous example. So you have x minus 1, y minus 2, z minus 13. Dot product with 2, 4, and negative 1 equal to 0. You see, from here I can have 2x minus 1 plus 4y minus 2 minus z minus 13 equal to 0. And that is the equation of the tangent plane to the surface. Next question, find the angle of inclination of tangent plane to the surface at a given point. Here we need to find angle of inclination. Angle of inclination. So we know that, right? We have formula. Please, I'll make a formula sheet for you and print to the test. What is the formula of that? That is cosine of theta equal to dot product with the k, and then gradient of f. Actually we have the following one. Here you have, here's your plane, right? And here suppose this is some kind of, x or y plane. Because angle of inclination is the angle between this plane and then x or y plane. So how to see that? This is gradient vector. This is the gradient vector, right? Because that is normal vector to this tangent plane. And this is the k, right? K is 0, 0, 1. This is z, you see, in z direction. So basically, this angle is this angle are equal. So instead of finding this angle, we find this angle, right? Means we have to find angle between these two vectors. And we know the formula from very first chapter of this course. So here we have x squared plus y squared plus z squared equal to 26. And the point is 3, 1, 4, right? I write f equal to x squared plus y squared plus z squared minus 26. And then I find gradient of f. Let's calculate at 3, 1, 4. That is 2x, 2y, and 2z, right? At 3 and 1 and 4. So what's that? That is 6, 2, and 8. 6, 2, and 8. So that is gradient vector at that point. And then you just apply dot product divided by norm of that, and you get the answer. So cosine theta, dot product of that, you see this is 0, 0, 1. So when I take dot product, I have 8 only. So I have 0, 0, 1 times 6, 2, 8 over norm. I write directly square root of 6 squared plus 2 squared plus 8 squared, right? And that is 8 over square root of 6 squared is 36, 4, 46, 64. So I have 36 is 40, I have 104. And you apply the inverse, a cosine, you can find theta. Okay, next question. Find a point on surface at which tangent line is horizontal. So this is also a very standard problem, in calculus 1. You need to find x where tangent line is horizontal, right? But for calculus 3, we also have the same problem. So if tangent line is horizontal, that means all directional derivatives, are equal to 0. Directional derivatives. If tangent line horizontal, it looks like this, right? Or looks like this. Surface, something like that. And here you get this, right? And all directional is equal to 0. So in that case, the normal vector should look like this. That is gradient vector, right? This gradient vector. And gradient vector has the same direction with the z. That is just scalar of 0, 0, and 1, right? Don't forget about that. Okay, so basically we have to find all directional. I write here this equivalent to all directional derivative are 0. Okay, all directional derivatives are 0. What is directional derivative? Let's do a short review about that. Du means derivative in direction u is equal to delta f dot product with u, right? And this equal to 0 for any u. For any u, let me see. Is derivative equal to 0 for any u? So basically, in this case, let me maybe let me fix this a little bit. Okay. So here's horizontal. So you take this derivative, then that is your normal vector. So the normal vector delta x should looks like this. But at the same time, this normal vector is perpendicular to any directional vector. Directional vector equal to 0. All right. So so basically, let's calculate. If we have function f. Here we have surface looks like z equal to 6 minus 4x squared plus y cubed, and I can write f of x and y and z, right? As usual, we write that it's just y cubed minus 4x squared minus z, and then plus 6. Let's find gradient of this function. That is 98x. And then 3y squared, and then 91, that is gradient, right? So actually you can see in this case, so delta x has equal to lambda, right? 0, 0, 1. So this should be equal to lambda 0, 0, 1. From here, I can see x and y should be equal to 0, 0. X and Y should be 0, 0. That's it. And then, yeah, and there is only one point where, you know, this guy is scalar product, scalar multiple of this, because this is just 0, 0, and okay. Next question. This is the last question about relative axiom and set of points. Use the second derivative test if applicable. All right, so let me write it down. X and y equal to negative x squared minus 3y squared plus 6x minus 6y minus 15, right? First, we need to find all critical points. Critical points. That is the first step. But what is that? That is fx equal to fy equal to 0, or f of x or f of y does not exist. So that is critical point. But this function is polynomial, we are good, right? So just the second case could not happen. We have first case only. So what is f of x? That is negative 2x plus 6. Set this equal to 0. Fy, that is negative 6y minus 6 equal to 0. From here you can find x equal to 3 and y equal to 1. So this function has only one critical point. And then here they ask you to, they ask us to find saddle point, right? They ask us to find saddle point. So let's find second derivative. Fxx and have I take the derivative of this, I get negative 2. And then fxy is 0, fyy is negative 6. And then you calculate d. What is d? D is fxx, fxy, fyx, fyy. Determinant of this guy, so you get negative 2, 0, 0, and negative 6, which is 12, right? Greater than 0. Greater than 0. So what does it mean? That means d is always greater than 0. So basically, this function does not have any saddle point. Does not have any saddle point. And because this function has saddle point, even only if at some point d should be less than 0. Remember that. So in this case, d greater than 0, and fxx is negative. So we have this d greater than 0, fxx negative, or this point should be maximum. Of course, this point is local maximum, and this also global maximum too. So I think that is all problems in this practice test. This long a little bit, but some problems can be solved really fast. So I hope that you practice a little bit and then be prepared to the test after the break. Okay.